So for algebraic products, guys, well, products, when you see the word product in math, it means multiplication, right? And algebraic products simply has to do with multiplication involving algebra, right? So unknown terms like, well, variables, I should say, variables like X and Y and that kind of thing, right? But more specifically, what we're going to look at today is the expanding, um, first just single brackets and then double brackets. So for example, well, just you may recall the distributive law, which is can be summarized by if you have A multiplied by B plus D, this would be to expand these brackets, you would multiply A times B. So you'll say A times B, which gives me AB. And then you'll multiply that same A by D, which will give me AD. And of course, it's positive. It's A times B, which will be positive AB, and then A times D, which would be positive AD. So we're going to use the distributive law to expand brackets. All right. The whole concept is based on the distributive law. All right. When you are using the distributive law, you multiply the term on the outside by each term on the inside. So let's look at some examples. So if you have, let's say you had 2 by x plus 1, well, to expand these brackets, you'll say 2 times x, which will give you 2x, and then 2 times 1, which gives me 2, right? Similarly, if I had, let's say I had 3 times x minus 1 instead, well, this will give me 3 times x, which is 3x, and 3 times negative 1, which gives me minus 3. Okay? You can also have like let's say you had 2x, for instance, on the outside. Well, that would be 2x by, let's say we have, sorry, I didn't even write out the whole question and already working it out for some weird reason. So 2x times x minus 3. It's the same rule. I'll say 2x times x, which is 2x squared, and then 2x times minus 3, which is minus 6x. So the distributive law is used to expand brackets or to remove brackets. And to do it, you multiply the term on the outside by each term on the inside. Okay, let me do one more example and then I'm going to give you all some to try. So let's say I had 3a times e plus 2a. Again, this will be 3a times b, which is 3ab, and then 3a times positive 2a, which will be plus 6a squared, since a times a is a squared. All right. So that's the whole thing right there. It's nothing, that's it, right? It is nothing more complicated than that. It is simply that you multiply the term on the outside by each term on the inside. So I want you all to try these for me. And you're going to send this to me on WhatsApp, okay? Those of you who can. So you're trying these. Good. Please try these. So first is 4 times 2 plus 3b, 3a by 2a minus b, x times x plus 2, 4x times 3y plus 2z, and then 2n times the 3p minus 5q. So please try these for me, guys. I want to see your efforts on WhatsApp. So send it to me. on the screen, right? So we had this first one, 4 twos are 8, and then 4 times 3b will be 12b. Then 3a times 2a is 6a squared minus 3ab, because 3a times minus b will be minus 3ab. X times x is x squared. X times 2 is 2x. 4x times 3y will be 12xy plus 4 times 2 is 8, and then x times z is x, oh, no, it's a space, xz. And the last one, 2n by 3p, 2 times 3 is 6, n by p is np. And then 2n times minus 5q will be minus 10nq. Excellent work, all of you. Everybody got it all correct. So very proud of you guys. Let's move on. Let us now, I want to group the brackets and simplify, right? Because sometimes that, I find that gives students some trouble. So let's look at how some examples like that. So for example, if I had um, 2 times x plus 1 plus 3 times x minus 1, right? And I have to simplify these. So first, I remove my brackets, just like we did before. I say 2 times x, which is 2x, and 2 times 1 is 2. And then I say 3 times x is 3x, and 3 times negative 1 is minus 3. So then simplifying, I group my like terms. Now you don't have to write it over if you don't want to, but I'm just writing it for explanation purposes, right? I'm going to group my like terms. So it's 2x plus 3x. So this would be, I'll put the plus 3x here. And then I have 2 minus 3. So this would be 2x plus 3x is 5x, and 2 minus 3 is negative 1. It is important when you are moving the terms around that you make sure you keep the sign that is in front of it, right? Because this is, for example, this is 2x plus 2. So wherever I put 2 in this expression, it must be plus 2. Look, I forgot the plus sign here. Oops. Yeah, so it must be plus 2. And likewise, I have minus 3 here. So wherever I'm moving minus 3 in the expression, it must always be minus 3. The only time that minus would change in front of that 3 is if I was moving it from one side of the equation to the other side of the equation. But this is not an equation, it is merely an expression. So I'm just simplifying as I go along. You cannot solve an expression, you could only simplify it, right? But it is important that you move with the sign. So if you're gonna write over, if you're gonna write line 2 that line 3 that I have here, you have to make sure that you have the correct sign in front of the term. Okay, so it's plus 3x, so this would be plus 3x over here. And then it's minus 3, so it continues to be minus 3, doesn't change to positive 3, okay? Let's look at another one. Let's say I had um 4 times y plus 2 minus 2 by y minus 3. All right, so let's see what we got here. First things first, we remove the brackets. So 4 by y is 4y, and then 4 times 2 is 8. And then, but here you have minus, right? So this will be minus 2 by y, which gives me minus 2y, and then minus 2 by minus 3, which gives me plus 6. And then I group my like terms. So group in my like terms, I have 4y. This will not be plus, it will now be minus 2y because I'm moving minus 2y to the closer to the 4y. So this will be my 4y minus 2y plus 8 plus 6. And that gives me 4y minus 2y, which is 2y. And then 8 plus 6 is 14. So my answer there is 2y plus 14. Now, in the event that you do not have a number in front of the bracket. So for example, let's say I had Let's say I had 3a by 2 plus y minus um, minus y, right? In the event that you see you do have a number here, you're just gonna pretend like it's or not pretend, but use a one in front of it, right? So it's as if you're saying minus one. So you're gonna expand your brackets, 3a times 2, which is 6a. 3a times y is 3y. And then minus 1 times a would give me minus a. And minus 1 times minus y gives me plus y. And then I group my like terms. So the only two like terms here are the a's because 3ay and y are two different terms, okay? So this will be 6a minus a plus 3ay plus y. So finally, this whole thing will be 6a minus a, which is 5a, and then 3a plus y. 3ay, sorry, plus y. You cannot simplify, you cannot add y to 3ay. They are not like terms. They could only add ays to other ays. Okay? Ay literally means a times y. So it's not the same as y by itself. And like I said, if you have no term, no number or letter term in front of the bracket, just put a one there. All right. So you're just gonna be multiplying minus one by a and minus one by minus y or whatever you have in the brackets there. Cool, guys. I want you all to try some where you're simplifying, where you have the double brackets and not double brackets. Sorry, this is not double brackets. Where you have more than one term with brackets and you have to simplify it. So you're gonna try these for me. Careful with your signs, okay? You know what? I want to put this on another page so that I'll have enough space to work it out afterwards. So you're trying for me. Be careful with your signs, guys. Make sure that you multiply minuses by minuses to give you plus. Same signs give you a positive answer. Different signs give you a negative answer with multiplication and division.
You see, because I realized that he cried.
All right, guys, so try these for me, please. Remember, remove your brackets first, pay attention to your signs, and then group your like terms. Add or subtract only like terms. Guys, I'm gonna do it even though some of you already sent it and most of you got through with them, I'm still gonna do these solutions here, okay? Just in case anybody needs any further clarification. So the first pair of brackets, this is 5 by x, which would be 5x, and then 5 times 2, which is 10. 4 times x is 4x, and then 4 times 3 is 12. Group in your like terms here. I'm just putting this up here because of space, right? Would be 5x plus 4x, right? I'm writing it. 5x plus 4x plus 10 plus 12. And that gives me 9x plus 22, all right? The second one, this first bracket, 3 times 1 is 3. 3 times minus a is minus 3a. Then 2 times 1 is 2, and 2 times minus a is minus 2a. So taking that over here, grouping my like terms, I will get, I have 3 plus 2, and I have minus 3a minus 2a. So this gives me 3 plus 2, which is 5, and minus 3 minus 2 is minus 5. So that'll be minus 5a. Number 3, first pair of brackets, 2 times 3x, which is 6x, and 2 times 1 is 2. Minus 4 by 2x will be minus 8x, and minus 4 by minus 2 is plus. So then grouping my like terms, I would have 6x minus 8x plus 2 plus 8. So that gives me 6x minus 8x is negative 2x, and 2 plus 8 is 10. Number 4, I have 3a times b, which is 3ab. 3a times minus 5c will be minus 15ac. 2a times b is 2ab, and 2a times minus 2c will be minus 4ac. Group in my like terms, I get 3b plus 2ab minus 15ac minus 4ac. And that gives me 3 plus 2, which is 5, so 5ab. And then minus 15 minus 4 is minus 19. So that'll be 19 minus 19ac. The last one, I was supposed to put 1 here, but I put x instead. And that would just, you could like literally work this out separately and then multiply by x. Like you could say 4x plus x is 5x and then multiply by x on the outside, right? But I didn't spot that I did that until I was doing it myself just now. Anyway, x by x is x squared. X by 3 is 3x. X by 4x would be 4x squared, and then x times x is x squared. So that gives me x squared plus 4x squared plus x squared plus 3x. So this will be x plus x is 2x squared. Well, x squared plus x squared is 2x squared plus 4x squared will be 6x squared. And then you have 3x. So that would be the answer. Zara, you went a step further and I think try to factorize 6x squared plus 3x. It'll be 3x into 2x plus 1, not 2x squared. But don't worry, we're gonna get around to that just now. So far, so good. Those of you who didn't send me your work, I hope you understood what you were doing. And if you didn't, and you're still confused after I've explained this, please let me know. Or please send me so that I could see your effort. At this point, we are going to multiply double brackets, right? So we're looking at the product of two brackets. The product of two brackets. And let me show you what I mean by that. Maybe y'all would have done this before, I'm not sure, but we're gonna do it anyway. So the product of two brackets, it's like if you have one pair of brackets. So you have A plus B by another pair of brackets, C plus D, right? So the strategy here is that each term in the first pair of brackets must be multiplied by the entire second bracket. So you do, this will be, you'll say A times C plus D first, and then you'll do plus B, that's the second, let me use a different color, sorry. And you'll take plus B, which is the second term in the first bracket, and you multiply it by the second pair of brackets, C plus D. So you're multiplying the first term from the first pair of brackets by the entire second bracket, and then you're multiplying the second term in the first pair of brackets by the entire second bracket. So that's one way so you could write out this extra step here and then you simplify. So this would end up being A times C, which is, I don't want to use green again, sorry. Yeah, so this will end up being A times C, which is AC, plus A times D, which is AD, and then B times C, that's BC, plus B times D, which is BD, right? You can do it like that, or you can go directly from the first line straight to this third line. Let me show you how. I personally have found that students do better when they write out this second line because it's just like what you've been doing all along, right? It's just like expanding one pair of brackets. So I find that sometimes when students write out the second line, I find that they tend to do better with it. However, let me show you how you can go from the first line straight to this third line. So if you have A plus B times C plus D, another way you could do it is you can say directly from here, you could say A times C, right? So the first term times the first term. So that would be AC, and then A times D. So that would be plus AD. And then you take B times C, so that's plus, so it will be plus BC, and then B times D. So this gives me plus BD. As you can see, it's the same thing that I got, right? And actually it is really the same strategy that you're using as well. It's just that you write it a little differently. You write this extra line. All right, so let's see how this looks with some numbers so that we could group our like terms. All right. So let's say we had, let me show you an example, and we'll do both methods, okay? So let's say I had 3x plus 2 times x plus 4. All right. So using this first method here, I'll take 3x and I'll multiply it by the full second bracket there. So 3x by x plus 4. And then I take the other term in the first pair of brackets, that's plus 2, and I multiply it by x plus 4, the second bracket. And then I simplify just as I've been doing before. So I'll say 3x times x is 3x squared. 3x times 4 is 12x. 2 times x is 2x. And 2 times 4 is, and then I just simplify from there because I have some like terms, right? I have two terms in x. So this would give me 3x squared. 12x plus 2x is 14x plus 8. And that would be my answer. All right. Now, using the second method, which is just going from the pair of brackets straight to the third line, I'm writing over the question, 3x plus 2 by x plus 4. And I'm going to just take the first term. So I'm going to take 3x by x. That gives me 3x squared. And then 3x by 4, which gives me 12x. And then I will take 2 times x, which gives me 2x. 2 times 4, which gives me 8. And then simplifying now, I will get 3x squared. 12x plus 2x is 14x plus 8. So I still get the same answer, right? So you, however, use whichever strategy you prefer, whether you prefer the first one by writing out the second line, or just going straight from the bracket straight to the expansion, right? I recommend this first one, but I have no problem with you doing it in the second way as well. I'm gonna do a few more examples with you though. So let's go. Right. So let's say we have x plus 2y by 2y minus c. Okay. So this would be x by the second pair of brackets, 2y minus c, plus 2y, that's the other term in the first pair of brackets, by 2y minus c. And then I simplify. X by 2y is 2xy, and x by minus c is minus xc. And then 2y by 2y is 4y squared, and 2y by z is minus 2yz. So I don't have any like terms there, so that would be my final answer. If you wanted to go straight from the brackets to the third line, you'll say x plus 2y by 2y minus c, and you'll say x times 2y is 2xy, and then x times minus c will be minus xz, and then 2y times 2y, which will give me 4y squared, and 2y times minus c, which gives me minus 2yz. Still gonna get the same answer. One is just you're gonna skip out right in that full second line. Okay. Um, let's do another one. Say I had um 3x 3x minus 2y times 5 minus z. All right, so I take the first term and multiply it by the second pair of brackets. And then I take the second term minus 2y and I multiply it by the second bracket. So 3x times 5 is 15x, and 3x times z is minus 3xz. Minus 2y times 5 will be minus 10y, and minus 2y times minus z will give me plus 2yz. Again, here I do not have any common terms, so I will just leave it as is. Right, let's see another one. Say I have x minus 2 by x minus 3. So this will give me x times x, which is x squared, and then x times minus 3, which is minus, oh, sorry, I forgot I was using the strategy. So x by x minus 3 minus 2 by x minus 3. So that gives me x times x, which is x squared, and x times minus 3, which gives me minus 3x. And then minus 2 by x, which is minus 2x, and minus 2 by minus 3, which gives me plus 6. Well, I do have like terms here because I have two terms in x. So this will be x squared minus 3x minus 2x is minus 5x plus 6. And that's your answer. Are you all ready to try some? Or you want me to do a few more examples? Let me hear your thoughts. Um, Josh, oh, sorry, Josh, I forgot your mic isn't working. Matthias, would you like me to do some more examples before I give you some to try? Or are you good to
Yeah, man,
try?
you could do one more.
Okay, I'll do one more. Let's go. So let's say I have um 2x plus 3 by x plus 2, right? So I'll take this term, 2x, multiplying it by the full second bracket. And then I take the second term from the first bracket, that's plus 3, and I multiply it by the full second bracket, x plus 2. So this gives me 2x times x, which is 2x squared, and 2x times 2, which is 4x. And then 3 times x is 3x, and 3 times 2 is 6. So simplifying, I get 2x squared. 4x plus 3x is 7x plus 6. All right, Safira. So should I do another example, or are you ready to try?
Ready to try this one.
All right, all right. Anybody else wants me to, if anybody else wants me to do another example, let me know. I don't mind. All right, so I'm gonna try to just fit it on the same page so that you can see it while you're doing your working, okay? So you're gonna try for me 2a plus b times 3c plus d, 7x minus 2y times 3 minus 2z. Three p minus q by 4p plus q plus 2 by x plus 7 m minus 7 by m minus 8. And finally, 5x plus 2 times x minus 2. So you're going to try these for me. Right. So the first one was the 2a plus b by 3c plus d. Got it? So this will give me 2a by 3c plus d plus b by 3c plus d. So working this out, 2a times 3c will be 6ac. And 2a times d is 2ad. And then you have b times c, so that's 3bc. B times d, which is bd. Practice if you have it. There are no there are no like terms here, so it cannot be further simplified. Okay, number 2. Number 2 is 7x minus 2y, 3 minus 2z. 7x minus 2y times 3 minus 2z. Okay, so this gives me 7x by 3 minus 2z minus 2y by 3 minus 2z. Make sure that these two signs are the same, right? This is minus 2y, so here it needs to be minus as well. It doesn't change. right? Up here, it was 2a plus b. So then here, it would have to be plus b again, right? So it's the same sign. Okay. So simplifying, we get 7x by 3, which is 21x. 7x by minus 2z is minus 14xz. Minus 2y by 3 is minus 6y. And minus 2y by minus 2z will be plus 4yz. Okay. Number 3 was 3p minus q by 4p plus q. 3p minus q by 4p plus q. See what that is. So this would be 3p times 4p plus q. Then remember, it's minus here. This will be minus q, not plus, minus. So minus q by 4p plus q. And then expanding 3p times 4p will be 12p squared. P times p is p squared. So that's 12p squared. And 3p times q will be 3pq. Minus q times 4p will be minus 4. Now qp and pq is the same thing, okay? Because I already have pq written here, I'm going to just write pq here as well, just so that I see that it's the same variable, right? pq is the same as qp. And then minus q times plus q will be minus q squared, since q by q is q squared, and a minus by a plus is a minus. So then this gives me 12p squared, 3p minus, sorry, 3pq minus 4pq. Well, 3 minus 4 is negative 1, so this will be negative pq, so minus pq minus q squared. That's your answer. 12p squared minus pq minus q squared. Number 4, x plus 2 by x plus 7. This will be x times x plus 7 plus 2 times x plus 7. Notice again, I'm showing you this. It's x plus 2. So then here would be plus 2 as well. All right. So expanding my brackets, I have x by x, which is x squared. X by 7 is 7x. 2 by x is 2x. 2 by 7 is 14. So this gives me x squared. 2x plus 7x is 9x plus 14. Number 5 was m minus 7 by m minus 8. Minus 7 by m minus 8. So this gives me m times m minus 8 and minus 7 times m minus 8. Remember, it's the first terms, right? Again, just to show you, it's minus 7. So this is minus 7 here. So this would be by m, which is m squared. M times minus 8 is minus 8m. Minus 7 times m is minus 7m. Minus 7 times minus 8 is plus 56. And then I could simplify this to give me m squared minus 15m plus 56. And then the last question, which was 5x plus 2 by x minus 2. 5x plus 2 by x minus 2. That gives me 5x by x minus 2 plus 2 by x minus 2. So I end up with 5x times x, which is 5x squared. 5x times minus 2 is minus 10x. 2 times x is 2x, and 2 times minus 2 is minus 4. So finally, this answer would be 5x squared minus 10 plus 2 is minus 8x minus 4. And that's the final answer. All right. So let's take a short break, guys. Let's take a short break for like 10 minutes and then we're going to come back and do some more of these. If you would like me to um see, yeah, let's take a break. Let's take a break for 10 minutes. Make sure to copy down the correct thing if you had any errors, huh? So yes, be careful with your signs. It's very easy to mix them up. So make sure that if you're doing this method, it's plus. And this one is like plus b, right? So the sign of the second term here, it's the sign that is in the bracket itself. So like this one is 2a plus b. So here you would have plus b times the second bracket. Here it's minus 2y. So here it'll be minus 2y times the second bracket and so on. So be careful with those signs. Remember, in multiplication and division, same signs result in a positive answer and different signs result in a negative answer. So therefore, two negatives, they're the same sign, so two negatives will multiply or divide to give you a positive answer. And also different signs, so a positive and a negative, or a negative by a positive will give you a negative answer. Right. So let's look at what do they mean when you see if you see something, if you see x plus e to be squared, this does not mean, right? It does not mean, this means is not equal to. This is not equal to x squared plus e squared. All right. So for instance, if you saw x plus 2 all to be squared, this is not equal to x squared plus 4. You do not square the terms inside. That's not what it means. Because x, for instance, x plus a all to be squared is actually equal to x plus a multiplied by x plus a. Remember that to square something means you multiply it by itself. Because this is within brackets, so it's x plus a, all to be squared, it means you have to multiply the entire bracket by itself. So x plus a, all to be squared, will actually give you x squared plus 2ax plus e squared, right? I just jumped straight to the answer, right? But it will be the same steps that we've been doing all along. Actually, let me do it. I don't want you all to just think I came up with that out of thin air. So this will be x by x plus a plus e by x plus e. So that gives me x by x, which is x squared, and then x by e, which is ex, plus a by x, which is ax as well. And then e times e is e squared. So this gives me x squared. Ax plus ax will be 2ax plus e squared. All right. So then how I have, like if I had x plus 2 then, all to be squared, then that would be equal to x plus 2 multiplied by x plus 2. And that gives me x by x, which is x squared, x by 2, which is 2x, by x, that's 2x, and 2 by 2, which is 4. And together, it'll be x squared plus 4x plus 4. All right, guys. So please make a note of this. This is very important. I have seen students time and time again make a mistake with this part here, right? Pay attention to it. So x plus a all to be squared is not equivalent to x squared plus e squared, right? This is actually x plus a all to be squared is actually equal to x plus a times x plus a. So if you had x plus 2 all to be squared, it'll be x plus 2 times x plus 2. And the same applies if it was minus, by the way. Same applies. So like if you had, for instance, if you had x minus a all to be squared, this is the same as x minus a times x minus a. And expanding the brackets, you'll end up with x squared minus ax minus ax plus a squared. So that gives me x squared minus 2ax plus a squared, since minus 1 is minus 2. Okay? These are like some special ones that you should try to not memorize because there's a strategy for it. So whenever there's a strategy for it, don't try to memorize like just if you see x plus a squared, well, that would be x squared plus 2ax plus a squared. You might remember it like that, and that's fine. But more importantly is that you remember how to work it out, right? And then there's also one that is, it's going to come up soon, and it's something that you have to learn how to recognize. It's x, let's say we have x plus e times x minus e. This is going to give me x times x, which is x squared, x times minus a is minus ax, a times x is ax, and then a times minus a is minus e squared. So this answer will actually give me x squared. Well, minus ax plus ax will be 0 because this is minus 1 plus 1. So that will be 0. So it'll just be x squared minus a squared, right? So this is something that you're going to see me bring up in the future. It's called a difference of squares. All right. And similarly, if you had the first brackets instead as the minus, so if you had x minus a by x plus a, still going to give you x squared minus a squared. Look, x times x is x squared. X times a is ax minus a times x is minus ax, and minus a times a is minus a squared. Again, these two will cancel out because it's plus minus, which will be 0. So this will be x squared minus e squared. So it's the same thing. It doesn't matter with this one whether you have the minus in the first bracket or the second bracket. You're still going to get the same answer, and it is called a difference of squares. So all of these are things that you need to really make a note of, right? You need to remember these. I see students up until my Form 5s still make mistakes with this, right? So please make a mental note of it and also like highlight it or underline it or something in your notes, right? Um, so I'm gonna give you all some to try for me with these just these squares, right? So try for me, trying x plus y squared. Sorry, x plus y all to be squared. 2x plus 1 all to be squared. Plus 2y all to be squared. X minus 2 all to be squared. 3x minus 1 all to be squared. So please try these for me. Okay, guys, so this would be x plus y plus y, and that would give me, my final answer will be x squared well, my second line will be x by x, which is x squared. X times y is xy. Y times x is xy as well. And y times y is y squared. So my final answer here will be x squared plus 2xy plus y squared. Only writing it across like this because I don't have enough space, right? But you, of course, will write it line by line. This one, 2x plus 1, all to be squared will be 2x plus 1 times 2x plus 1. And that's going to give me 2x times 2x, which is 4x squared. 2x times 1 is 2x. 1 times 2x is 2x. And then 1 times 1 is 1. So this gives me 4x squared plus 4x plus 1. This one would be x plus 2y times x plus 2y. So it's going to give me x times x, which is x squared, x times 2y, which is 2xy. 2y times x is also 2xy, and 2y times 2y is 4y squared. So simplifying, I will get x squared plus 4xy plus 4y squared. And then here I have x minus 2 all to be squared, so that'll be x minus 2 by x minus 2. And that gives me x times x, which is x squared, and then x times minus 2, which is minus 2x. Minus 2 times x is minus 2x, and minus 2 times minus 2 is plus 4. So this gives me x squared minus 2x is minus 4x plus 4. And the last one, 3x minus 1 all to be squared will be 3x minus 1 times 3x minus 1. So that gives me 3x times 3x, which is 9x squared. 3x times 1, that's minus 3x. 3x, and then minus 1 times 3x, which is minus 3x, and minus 1 times minus 1 is plus 1. So the final answer will be 9x squared minus 6x plus 1. And then the last thing that we're going to look at today, guys, is your difference of squares. Right? Your difference between two squares or your difference of squares, that was this one here, right? So your difference of squares, you have to remember this because when we move on to quadratics and factorizing quadratics, it's an important thing to be able to spot. When you have a difference of squares, of two squares. And why do we call it squares? Well, there's two square numbers. A square number is a number you get when you multiply another number by itself. So for example, a square number will be x squared because that's x times x. 4 is a square number because that's 2 times 2. 9 is a square number, that's 3 times 3. Um, Even like if you say 25x squared, this would be a square number as well because 25x squared would be 5x times 5x, right? 36y squared is a square number because that's 6y times 6y. So you're looking at the coefficient and the variable both being square numbers. So all of these here are square numbers, right? Your square numbers, again, it's a number that you get when you multiply another number by itself. So like in 100a squared, that is the square root of 100 is 10 and the square root of a squared is a. So 10a times 10a gives me 100a squared. All right. So a difference of squares is the factorization, right, would look like this. The product of two brackets where you have one with so it's the same terms but it's interchange signs. So like for example, if you have a plus 2 times a minus 2. Well, this is actually going to give me a times a is a squared, a times minus 2 is minus 2a, plus 2 times a would be plus 2a, and plus 2 times minus 2 will be minus 4. So this gives me a squared minus 2a plus 2a will be 0. So this will just end up being a squared minus 4. And as you can see, this is a square number, so this is a square, and this is also a square number. And of course, difference means subtraction. So that's how we came up with the term a difference of two squares, because they're both square numbers. So anytime you see, like, if you saw x plus 10, let's use a different number since I already have 10 up there. Another square number could be, well, let's just use any number actually. X plus 7 by x minus 7. Well, this will end up being x squared minus 7x plus 7x minus 49. And again, the plus 7 minus 7 will just cancel because it'll be 0. So you'll end up with x squared minus 49. So here you have a difference of squares again. Let's say um, we had 2x plus 3 by 2x minus 3. Well, this would be 2x times 2x is 4x squared. 2x times minus 3 is minus 6x. 3 times 2x is 6x. And plus 3 times minus 3 is minus 9. So this would give me 4x squared minus 9 because the plus 6x minus 6x will go to 0. So basically, once it's the exact same terms, but the signs are interchanged, meaning the signs are not interchanged, sorry, the signs are different. One is plus and one is minus. You can skip this whole second line and just recognize that it is a difference of squares. So it'll just be 4, well, whatever it is, the first term squared plus the second term minus, sorry, the second term squared. So if I saw x plus 8 by x minus 8, well, I expect the answer to be x squared minus 64 because it's the exact same terms. This is a difference of squares. X squared and minus x squared, sorry, and 64 are two square numbers. So again, like if I had 5x minus 2 by 5x plus 2, well, I would expect the answers to be 5x squared, which is 25x squared, minus 2 squared, which is 4, right? So the key, the main thing I would say is being able to recognize a difference of squares, all right? So that's the last thing that we're going to look at now. I'm just going to ask you to simplify some of them for me, some difference of squares, and uh, and then I'm going to give you an exercise which you can do for some extra practice. All right, so let's say you're going to try these for me. You could write out all these steps if you want, or you could just go straight to the answer because all of these that I'm giving you here are a difference of two squares. So you see how I started off by expanding as I usually would, but then I know the pattern already, so I could just work it out. Whichever you feel more comfortable with doing is fine. I'm using square brackets here because it's, if I use the curly bracket, sorry, the round brackets, it looks like C itself. Notice it doesn't matter if the plus is in the first bracket or the second bracket. It really doesn't matter. It's the same answer. Okay, good. Guys, try these for me, please. Okay, guys, let me put the answers. All right, so it's basically just the first number, the first term squared. That would be x squared minus the square of the second term. So 4 squared is 16. Square of c is c squared minus 3 squared, which is 9. X squared minus 12 squared, which is 144. 3x squared would be 9x squared. 3 times 3 is 9. X times x is x squared. Um, minus 1 squared, which is 1. 2a all to be squared will be 4a squared. And 3 squared is 9. 6a all to be squared is 36a squared. And 5 squared is 25. 10m all to be squared will be 10 squared, which is 100, and m squared. So 100m squared minus 1 squared, which is 1. And finally, 5m squared will be 25m squared minus 64n squared. And that's it, right? That's your difference of squares. So I'm going to send you all exercise to do for some extra practice. And if you think that you need a little more clarity on this topic, please let me know. There are videos that I've done before on it, like shorts as well. So it's like less than a minute, just going through how to expand double brackets. Okay, so please message me and let me know. But so far, based on what I've seen, I think everybody seems to be okay with it. Today we went through algebraic products, which is based on using the distributive law to expand brackets. We looked at expanding just a single bracket with a term in front of it using the distributive law, and then also expanding double brackets using two methods, um, where you just rewrite it using the first term multiplied by the second pair of brackets, and the second term multiplied by the second pair of brackets. We also looked at this method, which is also called the FOIL method, because it's first, outer, inner, and last, right? So this is called the FOIL method. Whichever method you found worked well for you, please do that one. And then we finally looked at two important distinctions, which is when you have a pair of brackets all to be squared. If you have, for instance, x plus a all to be squared, that is not equal to just the sum of the squares of the individual terms. Rather, it means the full bracket multiplied by itself. That's one fundamental thing that we looked at today. And then we also looked at how you expand a difference of two squares. And that was it.